In this lesson, we're going to continue talking about systems, but we're going to focus on inequality systems. And first, we need to know what a linear inequality is. So it's going to be similar to a linear equation, but it uses an inequality symbol. Because it's going to have a large range of answers, not just one answer like an equation. Because remember, in inequality, it represents multiple numbers, not just one. So your solution to a linear inequality, it's going to be all of the ordered pairs. That make it true. So with linear equations, we were finding, or systems of linear equations, we were finding one ordered pair that made that system true. But with inequalities, it's all of the ordered pairs. So you have more than one ordered pair. But we're just going to focus on just linear inequalities today, not systems of linear inequalities. So to determine which ordered pair is a solution, you want to know which ordered pair makes it true. So we're going to look at 2x minus 3y is less than 15. And we want to know if the four ordered pairs below it are true for this inequality. So what we're going to do is we're going to substitute each ordered pair into that equation. So remember or inequality. Remember, in ordered pair, your first is x and your second number is y. So when we plug in 2, 5 into the inequality, we get 2 times 2 minus 3 times 5 is less than 15. And then when we solve that, that is 4 minus 15 is less than 15. And 4 minus 15 is negative 11 is less than 15. And negative 11 is less than 15 is a true statement. So then, yes, this ordered pair would be a solution to this inequality. We can do the same thing with the second one. Again, your first number in an ordered pair is x, your second is y. We're plugging it into that same inequality. So 2 times negative 1 minus 3 times negative 7 is less than 15. And then solve. So negative 2 plus 21 is less than 15. And negative 2 plus 21 is 19 is less than 15. Well, this is not a true statement. 19 is not less than 15. So then no, this ordered pair is not a solution of this inequality. Go ahead and try those next two ordered pairs and see if their system or if they're a solution to this inequality. One other thing we need to be able to do when we're talking about linear inequalities is we need to be able to graph them. And this is really important when we start looking at systems, because this is going to show us our solutions to that inequality. So just like with linear equations, you want to put the inequality in slope-intercept form. Remember, that is y equals mx plus b. When you're putting it into this form, make sure as you're rewriting it, be careful of this. Be sure to flip that inequality symbol if you multiply or divide by a negative. Then once it's in that form and you graph it, you're going to use a solid line. So remember, when you draw your line through all those points, it's going to be a solid line if your symbol is less than or equals to or greater than or equals to. So basically, if it has that equals to underneath the inequality symbol, you put a solid line. Now, if it doesn't have the equals to underneath it, we call it a dotted line, or a lot of times we use dashes. And that's for if it's a less than or greater than symbol in your inequality. Then finally, you're going to shade your solutions. And you either shade above the line or you shade below the line. You're going to shade above the line if it is greater than or equal to. So all greater than symbols you shade above the line. And then all less than symbols you're going to shade below the line. Let's look at an example. 2x minus 3y is less than 15. So first we need to put this in slope-intercept form. Y equals mx plus b. So we want this y to stay where it's at. So that means we got to move the 2x over and we got to move the negative 3 over. So moving that 2x over, we're going to subtract by 2 on both sides. Negative 2x or 2x minus 2x cancels out. So you have negative 3y is less than negative 2x plus 15. So this is just like we do with equations. Then divide everything by negative 3. And you get y is greater than. So here I divided by a negative. So I had to flip that sign. So I get y is greater than a positive 2/3 x minus 5. So now that it is in this form, I can come over to my graph and graph it. And we graph it just like we do linear equations. We start with our y-intercept. So we're going to graph this y-intercept first and then our slope second. And then we're going to use the inequality symbol to shade third. So our y-intercept of negative 5, we would go down 5. And then from that y-intercept, we do our slope. So our slope is 2 over 3. So that means we're going to go up 2, right 3 from our y-intercept. So from our y-intercept, if we go up 2, right 3, and then we don't have enough room to do it again either direction, so we'll just have 2 points. So then when we go to do the third thing with our inequality, we have to remember if we have a solid or dotted line, because the inequality symbol doesn't have the equals to underneath it, it's going to be a dotted line. And again, like I told you, most of the time we use a dash, not necessarily a dot. And it needs to go all the way through your graph, just like with equations. And then all inequalities, when we graph them, has to have a shaded region. And because our equation says it's greater than, the shaded region is going to be above the line, which would be up here. So all of these ordered pairs in this shaded region represents solutions that make this true. Now, if the solution is on this line, because the line is dotted, none of those are true. If it were solid, it would be. So the only solutions to this one are going to be in that shaded yellow region. Let's look at another example. I want you to highlight number 1, and let's go to number 2. So number 2, it's already in y equals mx plus b. So we can begin by graphing it. Remember, we graphed the slope first, or the y-intercept first, then our slope, and then we use our inequality symbol. So our y-intercept is negative 1, so starting at our origin, we're going to go down 1. And then our slope is negative 2 over 1, which means we're going to go down 2, right 1. So from our y-intercept, we're going to go down 2, right 1. Down 2, right 1. Then, before you connect these all the way across, remember you have to look at your inequality symbol. So the symbol is less than or equal to. What that means is we're going to have a solid line that is shaded below because it's less than. So solid because of the equals to, shaded below because of that less than. So what our solid line looks like is just like with linear equations, a solid line going all the way through the graph. Then shaded below is going to be all of these ordered pairs below the line. So any ordered pair that you pick in this shaded region, if you were to plug it in like we did on the previous page and check it, it would make a true statement. If you were to pick a point on this line, so on that blue line, if you would pick a point, check it, it would also be true because it is a solid line. Go ahead and highlight 3 through 8. And remember, especially towards the bottom, you also have special cases just like with equations. So remember, if it's y equals or y inequality symbol, you're going to have a horizontal line. And if it's x equals, it's going to be a vertical line. So you can have special cases with those as well.